All right, let's review the first derivative test, and we'll think about a function. We only know this point of the function, and we know that the slope of the function is 0 at that point. So does f have a relative maximum or relative minimum at x equals a? So we're asking whether at the point, is there going to be a maximum or is there going to be a minimum? And what do we need to know to be sure that it's a maximum or a minimum? Well, we can look for the slope before the critical number, so we know that a is a critical number and we know that the slope is positive here and negative here, so that would tell us that there's a maximum. If we go from a positive slope to a negative slope to positive slope, we know that would give us a minimum. So that is these are the concepts we need for the first derivative test. Here we're looking for the actual max or the min, but questions that use the same procedure also just look for, ask for the intervals of where the function is increasing or decreasing. All right, so we have to find the derivative, and that's 2x plus 8. We need the critical numbers, and critical numbers occur when f prime is 0 or f prime is undefined. A critical number is -4. There are no critical numbers from a polynomial being undefined. It's never undefined. And let's organize this as a number line. We'll look at it as a graph, but we just don't specify the y values. We know that -4 is a critical number, so we're going to check a number to the right and a number to the left because we're looking for whether the slope is positive and then negative or negative and then positive. So we're going to find values of f prime. We want the slope at -5, so we put a -5 there. 2 times -5 plus 8. -10 plus 8 is negative. And we'll try a 0. 2 times 0 plus 8. We're finding the slope at 0, and that's positive. So now we have a graph, a part of the graph that looks like this, negative slope to positive slope. So we don't know the y values, but we know the graph is decreasing and then increasing. So from this work, we can answer questions about intervals of increase and decrease, and we can also answer the question about the relative extrema. So we say f of x is decreasing on -infinity to -4. F of x is increasing on -4 to infinity. F of x has a relative minimum at x equals -4 because f prime changes from negative to positive. On the AP test, you have to give this reason of why. If you said this and this and then said that, these would count as the reason, but a lot of times it's just asking for this or that. They don't ask at the same time. Okay, let's do the same question for this. Intervals of increase, decrease, and also relative extremis. So pause the video and try that one. We'll do the derivative. We want to find the critical numbers. That's where f prime is 0 or f prime is undefined. F prime equals 0. And we'll have, we can factor out 3x. So we're left with x minus 4. And that gives us x equals 0 or x equals 4. Polynomial is never undefined. So let's look at what's happening with the slope around the critical numbers. Critical numbers 0 and 4. So we have to check between them. We can pick any number between 0 and 4. And let's find the slope at -1. So put a -1 in here, and we have 3 times -1 squared minus 12 times -1. So that'll be 3 plus 12, and that's positive. And we'll put a 1 in there. We'll get 3 minus 12, and that's negative. And substituting a 5, 75 minus 60, positive. So we know the graph has a slope of 0 at 0 and 4, and it's increasing, 0, decreasing, increasing, 0, decreasing, and then increasing, increasing, negative, increasing, increasing, decreasing, increasing. Sorry about that. And we're going to say f of x is increasing on -infinity to 0. It's also increasing from 4 to infinity. Decreasing on 0 to 4. And f of x has a relative maximum at x equals 0 because f prime changes positive to negative. Okay, relative minimum at x equals 4 because f prime changes from negative to positive. All right, let's do the same question. We need to find the derivative. So power rule, 2/3 x to the -1/3, and the derivative of 4 is 0. So why don't we write it like this? And we're going to find the critical numbers. Critical numbers are when f prime is 0 or f prime is undefined. So a rational equals 0 when the numerator equals 0, but that never happens because the numerator is always 2. So I call it, it's not rational, but a fraction is undefined when the denominator equals 0. We need to know when the denominator equals 0, and that's when x equals 0. Critical number is 0, and we'll check to either side to see what's happening. What is the slope at -1? So if we put a -1 right here, that'll be a -1, and we get -2/3. The slope is negative. Let's find the slope at 1. So you put a 1 here, and that's positive. We know that the function is decreasing and then increasing. At 0, the slope is undefined, the derivative is undefined. That means there's going to be, it's not going to be smooth at 0. We don't need to know the details of it. For this question, we can just say that f of x is decreasing on -infinity to 0. F of x is increasing on 0 to infinity, and f of x has a relative minimum at x equals 0 because f prime changes from negative to positive. So that makes a minimum. All right, try the same, answering the same question for this function. Pause the video. We'll do the chain rule times the derivative of the inside, which is 1, and rewrite it. We have the cubed root of x minus 1 squared. We need to know when f prime is 0 and when f prime is undefined. For the critical numbers, f prime, this is 0 only if the numerator is 0, and 1 does not equal 0, so we don't get any critical numbers from that. The denominator is 0. We can divide by 3, it's still 0. We can cube both sides, it's still 0. Square root both sides, it's still 0. And then we get x equals 1. So let's see what's happening at the critical number. We'll check to the left and to the right. Find the slope at 0. If you put a 0 in here, we square the -1 to make it positive. So this is going to be positive. And then at 2, we have a positive squared, so that's positive. But we do know the slope is undefined at 1, and so we have something happening where the graph is increasing, goes vertical, and then increases some more. And we would say that f of x is increasing from -infinity to 1, and then from 1 to infinity. We can't say the function is increasing at 1 because the slope is undefined, so that's how we would answer it. And positive to positive, we say f of x has no relative extrema. guess we don't need to call that b. We know it's 0, and we have this is the graph of f. So let's look at, we need to sketch the graph of f prime. So let's find values of f prime by looking at the graph of f, and just space these out. We have a, 0, and c. So let's see, at a, what's the slope? This slope is 0 because we have a horizontal tangent line. So at a, the derivative is 0. At 0, the derivative is 0. And at c, the derivative is 0 because there's a horizontal tangent line. Then we look at the slope here. We make sure we don't say the slope is positive. Don't look at the arrow. We look at the graph. It's decreasing. So we have negative slopes. Then it goes to 0. Now we have positive slopes. Then we have negative slopes. And then positive slopes. So now we can sketch using these y values. We have a y value of 0 here, here, and here. And then we have negative y values. So negative y values leading up to a. Then the y values are positive. Then the y values are negative. And then the y values are positive. So this takes a lot of practice because it's easy to look at a graph and you're supposed to be looking at the slope and you end up looking at the y value, or vice versa. By making a table, it forces you to look at one thing at a time. All right, let's try this one. Okay, use the same strategy. We have the graph of f, and you need to sketch f prime. Pause the video and try that one. We have a, c, and b. Leave some space. We need slope. So we're looking at this graph. We want to find slope. We have positive slope, 0 slope, negative slope. So at C, the slope is 0. All of these have positive slopes, and all of these have negative slopes. So now we need to draw the graph of f prime. Now these are going to be y values of f prime. They're slopes of this graph, but now we need to switch the concept and graph positive values, 0, and negative values. So to graph f prime, we have the same x values, but we have positive y values here, a 0, and the negative y values, positive to negative. And then up here, make sure this is labeled as f prime. Okay, let's do that backwards. And now we're given f prime, and we need to see what f might look like. So let's make a table for f prime. X, f prime. We have a and b. And what do we know about the y values of this graph? The y values are positive, 0, negative. We have positive y values, a 0 y value. We have negative y values, 0, and then positive. So we're looking for a function that has positive slope, 0 slope. So we could say it has to have a positive, a 0, and then it's going to have negative slope, a 0, and a positive slope. And the 0 occurs, the 0 slope is at A, this 0 slope is at B. So this is a possible sketch of f, but we don't know any y values. So if I don't put the y-axis, I can say, well, that looks like that's a possibility. All right. Pause the video and try that one. Let's see what y values we have of the graph. And the y values are negative. At 0, the y value is, at A, the y value is 0. And then beyond A, the y values are positive. So we know that f has these slopes. So we have the graph of f is decreasing, and then has a slope of 0, and then increases. The slope of 0 occurs at A, but we don't know whether the graph is here or the graph is there, and that's related to solving differential equations. We end up with that. That's the constant of integration, but we're not covering it now. So this is the best we can do for this question. Okay, we'll stop there.